All right, this is our video lesson on systems of equations, and we're going to solve systems of equations graphically in this lesson. So the do now says, think about how you would try to set up this question. Chris goes to the cafeteria and he buys a pretzel and a water for $3. And Michelle goes to the cafeteria and buys 2 pretzels and a water for $5. And the question is, what is the cost of each item? So this is interesting. We have 2 items. We have a pretzel, and it's a word problem. So actually, I'm going to set up columns here. I have the cost of a pretzel and the cost of a water. And those 2 things can be different. And they're not necessarily related, but we know that if someone buys a pretzel and a water, total is $3. And if someone buys 2 pretzels and a water, the total is $5. So if I think about my variables, I don't know what the cost of a pretzel is. And I don't know the cost of a water. And you could call cost of a pretzel P and the cost of the water W, but I'm just going to call them X and Y for now. And then I know a pretzel and a water costs $3. So a pretzel and a water together totals out to 3. So my pretzel and my water, if I add up the costs, I get 3. And then Michelle goes and buys 2 pretzels and a water for $5. So I can write hers as 2 pretzels, 2 X's, plus 1 water is $5. Now I have 2 variables, X plus Y, X and Y, and I have 2 equations. And we want the cost of each item. If you notice, though, each of the equations is a line if we solve each equation for Y. So that's what I'm going to do. I'm going to subtract X from both sides. And I get Y equals negative 1X plus 3. That's my first equation. And then I want to subtract 2X from both sides down here. And I have Y equals negative 2X plus 5. And so I'm going to get 2 lines. So I'm going to graph both of those lines. So the black one I'll graph first. I'm going to start at the y-intercept of 3, 1, 2, 3. And I'm going to apply the slope of down 1 over 1. Down 1 to the right 1. Down 1 to the right 1. Down 1 to the right 1. Keep following that pattern. And then to graph other points, I can go up 1 to the left 1. Up 1 to the left 1. Up 1 to the left 1, etc. And there's the black line. There is the black line. Okay? And now I can graph the green line. And I can do it in the same fashion. At 5 here, I go up 5 on the y-axis. And I'll go down 2 to the right 1. Down 2 to the right 1. Down 2 to the right 1. And keep doing that until I get the general picture here. And I can also go up 2 to the left 1. Up 2 to the left 1. And I will get another line. So here is that line. Okay. And I'll put that in green. Actually, that'll be our green line for our green equation. And notice, these lines happen, first of all, actually, when you graph 2 lines on an axis, what you should do is label with the original equation, like so. And notice, the 2 lines actually meet. They meet at this location right here, which is the point 2, 1. And if you remember what X represents, X is the cost of a pretzel. And Y is the cost of the water. And what's interesting about this is if a pretzel costs $2 and a water costs 1, we would find out Chris bought a pretzel for $2 and a water for 1, and that ended up adding up to 3. Michelle bought 2 pretzels, so she bought 2 times 2, which is $4 worth of pretzels, plus a water, and that it added up to 5. This point of intersection is essentially where the two lines meet, meaning that the costs for the water and the pretzel are the same at that point for each of the situations. So that's how we can actually solve this problem graphically. You can graph the two lines and find out where they meet. And so the solution to this is a pretzel costs $2 and a water costs 1. And the solution, what we call this, is a system of equations. And the solution to the system of equations is a point. It's 2, 1. And in this particular case, it has a meaning. Now, we're going to do a lot of word problems with this as we go along, but that's the idea. The idea is that I can take two equations and find out the x and the y that make them both happen or make them both true at the same time, like the cost of the pretzel and the cost of the water. So I'm actually going to do two of them with you, and then that should be good for you to get the concept. So we want to solve the system of equations graphically. So basically, I'm looking for where the two lines will meet, and that will give me the x and the y that make both of the equations true. So I have 3x minus 4y is negative 4. And I have 2y plus x equals negative 8. And in order to graph these, we want to solve for y. So in the first example, I'll subtract 3x from both sides. I'll get negative 4y equals negative 3x minus 4. Divide by negative 4 everywhere. And so y equals 3/4 x plus 1. And so I can graph this line by starting my y-intercept at 1 and applying the slope. Up 3 to the right 4. Up 3 to the right 4. And if I wanted to go the other direction, I can go down 3 to the left 4. Down 3 to the left 4. And there's my line. And on the equation of the line somewhere, I want to write the original equation. 3x minus 4y equals negative 4. Move that up there. Whoops. Okay. All right. Then I have this second equation, which I'm going to do in blue. I'll do the work in blue. So I'm going to subtract x from both sides, and I'll get 2y equals negative 1x minus 8. Divide by 2, and I get y equals negative 1/2 x minus 4. So I'm going to graph that line. So I'm going to go down 4. I'm going to go down 1 to the right 2. 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 And once I get the general pattern, I'm going to go backwards. I'm going to go up 1 to the left 2. Up 1 to the left 2. And I hope you see, if you do that, the two lines are going to meet at a nice, neat point. And this equation is the original. I want to write the original they gave me. 2y plus x equals negative 8. And they meet at a certain point. And that point is called the solution of the system of equations. So they meet right here at this red point. And this red point is negative 1, 2, 3, 4, negative 2. So the solution to the system of equations is negative 4, negative 2. And that's how these all go. There's really no difference between these and any other problem. So there's one more I want to do with you, and it's going to be question number 4. Because question number 4, as you see, involves a parabola because it has an x squared term, okay, our old celebrity friend, and this guy is a line. So to graph the parabola, we use the calculator. So I have my y equals x squared plus 4x minus 5. And I look for the pattern on the calculator. So I'm going to go to my calculator, which I don't have open up. So I have my calculator open now, and I'm just going to type in, I'm going to press the y equals button, and I'm going to type in the x squared plus 4x minus 5. And then I'm going to do a second graph. And This is a parabola, so I'm looking for the pattern in the y values. So right now, if I go up 1, I think I'll find it. And here's my table of values. There it is. Okay? And that table you should write down, and you're going to plot the points. So -5, 0, -4, -5, -3, -8, -2, -9, -1, -8, 0, 5, and 1, 0. And so now we have our parabola. Looks something like this. And I'm going to write the equation on the graph. Then I have my line. So the line was y equals x minus 1. And I'm going to graph that line. So a line gets graphed completely differently. I have my y-intercept, which is -1, and I go up 1 over 1, up 1 over 1, up 1 over 1. That's the slope, 1 over 1. And I can go down 1 to the left 1, down 1 to the left 1, down 1 to the left 1. And if I made my parabola nicer, it should have gone through that red point. Let me redraw this real quick here. Okay, and if I keep going with my blue points from down 1 to the left 1, down 1 to the left 1, etc., there's my line. And now you'll see, it's interesting, the line and the parabola meet at 2 points. They meet at 2 points. They meet here at 1, 0, and here, so they meet actually at 2 points. One of the points is 1, 0, and the other point is 1, -1, -2, -3, -4, and down 1, 2, 3, 4, 5. So they meet at 2 points. So there are actually 2 points that make the equations, both of them, true. And the points are 1, 0, and -4, -5, and those are the solutions. And the rest of these, now that you have the idea, you should be able to do.